Okay, as everyone probably knows, yesterday UCSD announced that they were basically not closing campus, but courses are being moved online, and they're discouraging large meetings, et cetera, et cetera, et cetera. And of course, once that happens, UCSD can't wait too long to do the same, in part because administrators are always nervous about making the wrong choice, and then later on they get blamed for. So basically, 61 minutes ago, the president of the university sent an email out saying that, okay, after spring break, all classes except for a few exceptions are moving online, and the faculty want to continue doing in-class sessions. They have to ask for special permission, and between now and then, it's up to individual faculty what they're going to do. They're going to continue meeting in class, or they're going to move the course online. So some of the details, of course, are not spelled out. What about office hours? We still have office hours or not? Graduate advisors still have office hours or not, or things like that. Now, in the past, I've tried recording lectures in advance. And one is talking to a machine is not quite the same as talking to people in person. And so to record like a 5-minute version of the lecture takes like an hour. Why? Because like you start talking, like, oh wait, so you stop and you start over again, and then you start editing. So what I plan to do is campus supports Zoom, and so the live session, so you can connect, and even if no one's connected, I can pretend someone is there, so I can't stop talking. And so I'm testing it out today, so there is the ID, and so I will record them and then put them also online to make them available after class. And so my plan is to basically, when class is supposed to meet, I'll schedule a Zoom meeting. Now I don't know whether we should continue meeting in the class like this or not. My experience has been that with my classes at Health System Studies, once the classes are recorded, right, attendance really drops down. And already, like, well, it rained today, right? And people, when I first moved to San Diego, there was a storm, and I go home, listen to the news, like, there was a storm today, and like, there was, it rained, and that's a storm, but you sort of adapt, and so, I will send out details, tomorrow. My guess is that what I'll start doing is just recording from my office instead of coming to class.
Will you send instructions for how to use Zoom?
Yeah. There is, San Diego State, has a license for it, and so there's a San Diego State web page, and I can download Zoom, and then I can send out announcements. So here's the link. And I think, do I have it? Of course, basically, here we go. Is it? Yeah, the URL you want to deal with is And that should get you to a page where you can access San Diego State Zoom. And you should be able to download a client. I'll send out instructions. And we'll see how that goes in terms of I'm also recording the lectures the normal way too today, so we'll see. So if Zoom doesn't work, I'm going to back up right. And I must admit, it's taken me a while to understand why people are so panicked about this. And yesterday I came across an article that said, look, you know, there's two issues. One is we don't know, right? We really don't know how infectious it is. We really don't know mortality rate, you know, because we're not testing everyone, and they don't have a long record and history of it, right? And then another problem is that, you know, there is a vaccine for the flu, and so a number of people are vaccinated. And I assume if you had flu last year, you might have some immunity for flu this year. And so there's a certain percentage of population which is immune, which does two things. One is it slows the propagation because, you know, if half of you are immune, it's not going to spread as fast, right? But the other more serious problem is now basically there's no one immune to COVID-19, right? None of our immune system has seen it before, and so potentially we could all get it, right? And so even if the mortality rate is the same as the flu, the fact that everyone is susceptible, the death rate could be much higher, could be higher, right? It is going to wreak havoc on the world economy, but it'll be interesting. So that's all I know at the moment. I don't plan on asking for an exception to teaching in class. So I suspect after spring break, all the CS classes will be online.
For how long?
How long?
Yeah.
It says until the end of the semester, right?
Does that mean for exams?
I don't know what it means for the final. For the midterm, it'll just be take home.
So midterm will be project on one
Well, at some point I'll say it's online now, and then you grab it, and then there'll be a due date and you turn it in. There are systems which allow you to, you know, post an exam and have it timed, do the Blackboard. But you know, I don't trust those systems, and I don't know if they still do this, but for a while, San Diego State was sort of broadcasting classes to other campuses. And so there are rooms where the students go, and there's a big TV screen, it's the instructor, and there's cameras on the students, so when they ask questions, they can raise their hand, the instructor could see them, right? And so there's one case where, okay, there's an exam, and so the instructor sends the exam out to remote sites, and the students come in, and all semester long, they're like, there's a camera there, right? And there's two students in the remote classroom, and they're like, opening their books and talking to each other, and it's like, it's being recorded. And like, the text go like, do they know it's being recorded? And then you told the instructor, like, you know, you gotta watch this video because they're cheating, and like, okay. And it's too bad, because like, so to post an exam online and say, don't open your books is like, it's not gonna happen, right? So you assume the books are gonna be open, right? So all those types of questions you're asking in class exam, just get rid of it because it doesn't make any sense. You're just gonna, you know. In case you missed it, the president sent an email out an hour ago saying we're going online.
Except for the rest of the semester. It was after spring break, right?
After spring break, it's mandatory.
Oh. So what is it right now?
Voluntarily.
Okay. And yeah, I'm gonna have some questions.
Yes. So that's all I know about that. Any questions?
So I know you're recording right now.
Yes.
Does that mean we're gonna be online from here on out?
Well, I've been recording all semester long, except for a couple times when it fails, right? So you've been able to listen to the class remotely, but from now on, yes, I will be using Zoom to record the lectures and have a Zoom session so you can be able to stay at home and ask questions remotely, hopefully, if Zoom works properly.
Zoom's a great,
Yeah, it works.
great app.
Yeah, it works, right?
Yeah.
I mean, there will still be problems because you're still relying on the appropriate bandwidth between you, right, from here to the Zoom site servers and Zoom, right?
Yeah.
And even when we were doing interviews before we brought faculty on campus, and there were a couple times when it was like, oh, stop, you're breaking up, right? Can you repeat the answer to that question? I mean, that will happen. I mean, depending upon network traffic and so, you know, my current plan is to record both using Zoom and the software I'm already using. So if something happens with Zoom, at least I have something I can post online. You can look much later. It does make some things more difficult. And this happens when students start asking questions online. It's like, I'm having trouble with problem 3. Okay. I can't help you because I don't know what problems you're having, right? Problem 3. And so often that takes a much longer time because, like, even if they try and explain the problem, I have to figure out, you know, what's possibly going wrong, and after that I think, okay, what should I say, and how do I, you know, and often it takes like 3 or 4 back and forth before I understand what their real problem is and how to address it. Whereas in class, I mean, all of a sudden look at people like they're going, you know, okay, there's something wrong here, and now we can go back and forth, right? And also, you know, I know there's one set of students came in my office hours asking for questions on the current assignment, and they were like, they wanted me to tell them what to do, right? And since you're graduate students, I don't want to tell you what to do. I want you to figure out what to do, right? So I start, trying to lead them on the path, right? And like, they clearly want to say, just do this. Like, no. Let's talk about what are your options, and because it's, as soon as I tell you what to do, you stop thinking about what should be done, what could be done. And I know, I suspect you all have the same, look at the problem, and there's a solution over there, and we go look, right? And then, okay, yeah. And then next week is like, how'd that go? You feel like, I'm gonna solve it. And then you figure it out. Then I remember that much longer because now I figured out what's going on as opposed to just, that's what I do.
Are you still going to have office hours? Sorry if you answered this question.
That's a good question, and I assume so. And actually, as soon as I finish reading the president's email, I send emails to the chairman, okay, and what about office hours? And in particular, what about office hours for graduate advisors? Because, we got the wiki, right? So in theory, you could ask all the questions there, but the graduate student has a question about, now what do we do, right? They don't have access to my Blackboard classes, etc. So I assume I still will. But besides, the president made clear that San Diego State is still open for business, right? There's another question being formulated.
I don't know. I haven't got the email, but so does that mean the walking ceremony is going to get canceled too, probably as well? If they're going to cancel classes, right? That's a huge congregation.
Classes are not canceled.
Oh, I'm sorry. Moving them to remote.
Right.
Maybe everybody remotes into the ceremony.
I don't know what's happening.
Okay.
I suspect they don't know either, right? Like, right. Presumably they're hoping that the whole thing dies down in a month and then we're like back to normal. But they're worried like half of San Diego will be in the hospital and so it'll be interesting, and it'll be something to tell your grandkids. Great. And the problem is it could just be a one-time event, right? Or it could be like, well, every 5 years we get another big new crazy virus because there's so many people densely packed, right? That as soon as it gets spread, and what's scary is what's going to happen in India when the virus is there, right? High density, population density, and a lot of poor people. There's no health care, so it should just be like.
Have you heard of CRISPR?
What?
Have you ever heard of CRISPR?
Yeah. Oh, yeah.
Yeah, that's in the wrong hands. That could be a big problem too.
So there is one question about the current assignment. And if you look at the wiki, it's on the wiki. And so some of the files don't have all the columns. So what do you do? Well, one question is trash it. Maybe, right? The first question you have to ask is which columns are missing. you may not need those columns, right? If the columns are missing or ones we're not going to use, then we can just delete those columns everywhere and then we're good to go, right? But if those columns are needed, then the question becomes, well, are they needed for everything or just for some of the things, right? If you really need to know which columns are missing, what action do we take?
So I know in that article, about the taxi
Right.
thing, they were like doing like almost like an outlier check before they made any like analysis on it.
Yes.
Do you want us to do that in our homework? Before we like do any of the analysis?
You definitely want to start investigating the data. For example, there's columns missing. Now what do we write? Which columns are missing, right? Are there, is the data well formatted or not, right? That type of thing you want to do before you start doing the analysis, because if columns missing, you're sort of stuck, right? The outlier analysis. Yeah, you want to, I basically told you, don't, trips longer than this don't count, or more passengers than this don't count. But yeah, let you know what are those outliers. You know, right? It's like, any other questions? So last time we were talking about Spark, right? And so continue on Spark. So I backed up a little bit. So we're looking at these data sets with flights, where they start, where they ended up, how many flights are between those destinations. And there's various ways we can do. We can start just doing a select. So here we're selecting, these two columns, right? And then we just get those two columns, right? So it's nothing unusual. There's some different ways we can do this. And of course, the ones that are struck out are ones that work in Scala but not Python. And we can do some operations on each column, per column. So we can add operations, reducing comparison. There's a limited set of operations we can do per column. So I'm just doing something weird, right? I'm taking the count column and I'm multiplying by 2 and subtracting off the sign. It's nonsense, but it shows you the type of things we can do, and we get some bizarre, nonsensical results. But just showing you that we can perform operations on a column. And there's another way of doing it because of the expression, right? And now we can do something similar, but with expression, something I really don't like. The operation is now done as a string, And the problem with that is, of course, any sort of error, syntax error, typo, you only find out when you try and run it, as opposed to when you try and, at runtime. And then we can combine them into one operation. And then we can, select everything with the star, and then we can start adding columns. And then we can start aggregating, here I'm just counting the number of things that happen, counting distinct names, right? Right, so how many total flights were there? Well, there's 500,000. Destination, country name. How many distinct ones were there? Right, so here's where you can find which functions you can use like that. And it's sort of like, okay, now we can, right, add columns with a column. So we have multiple ways of doing several things, different ways. Renaming columns. Ready dates, well, we can do that. Right, there's a SQL function toDate, so we can then call that to actually take that column and convert to a date object. And then once you can do that, you have to work with all the different formats, date formats, but again, the function takes care of that. And again, this is a reminder that in Spark there's transformations and actions. So it looks like we're doing a bunch of passes, but we're not. We're just building up a plan. It's only when you actually execute an action does it all get. We can drop columns. We can add columns, right? We can. And we can, filter rows based upon various criteria. Nothing exciting. Again, they're obviously trying to make sure everyone's happy with it, having multiple ways of doing the same thing. Right? And we do multiple wheres. And it's branded. In Scala, we can do ORs, but not in Python. So you're gonna have to select, one and select the other, then union them together. Actually, can we do the ORs? Okay, so we can do ORs, right? We have to do it a different way. No, I can't do it that way. Distinct will give us distinct rows. We can do order by different columns, right? We can request limits. We only want the first 10. First 10. So take and collect are their actions, right? So they'll bring that results back to the master node, and take. You can specify how many you want. Collect brings them all back. Right. So when we do this, right, we're getting, basically a collection of rows. And so we can now look at the first row, right? But the row is an object which knows indexing, so we can now, right, index each individual column in that row. And we do it by location and by label. And then the all-important true panda. Because once you bring it back to the master node, the data structure is not in the format to start doing regular panda stuff on it. You have to convert it to a panda data frame. So you have to keep track, what world am I in? Am I in this Spark world, or I'm in the Python Panda world? Right, so I can use a union to actually take two data frames and combine them together. So I get them both. We can start getting random samples, and this is important because if you're training a model, typically you want to take the whole sample and divide it into training sets and test sets. Right, and then we can the seed to the random number generator. What fraction do we want to take, and do we want with replacement or without replacement? Right, so we typically want random split, and you basically tell it what percentage you want for each side, and then the seed. And then we can start having our training set and our test set. We didn't normalize, but So we talk about these functions, right? So a bunch of functions we can use. We can define our own functions to apply like that. Right. So there's this swapper, and then we can, call our Python function. And here again, we have this. We're now living in different worlds that are combining together, and we have to keep them all separate, right? So Spark is running the JVM, and as soon as we have Python code being applied to each element of a Spark data frame, now we have to go back out to the Python code, right? And that will be slower than calling in a built-in one. Yeah, well, that was only called in the name, right? We need to find on the data frame. And I'm missing a slide to tell you how to do this. So I'll have to work on that and see what happened to it. And if you apply your function to the wrong data type, you get a runtime error. Standard aggregation functions we can use, right? So we can aggregate, we can count, right? Sum, distinct sum, average, mean, all the standard sort of things you do. There's some data, compute the mean, the max, standard deviation, write a bunch of stuff. So we just all the statistical things you want to do. No problem. How many distinct elements are there? Right, so we have lots of like that. We can do group by. We've seen this before in pandas. Here's a bunch of data. Now, when I call group by, I can start, creating a sum, a mean, how many elements there are, right? And so for A, it's total is 9, so it's like 2, 3. Sideways is hard, 4, right? And then average and how many numbers we get. Not really exciting, right? It's like and the key thing to keep in mind here is that you're running multiple programs in parallel, right? Because when you do this, right, the master is going to send the work to worker nodes or threads, depending on whether you're on a cluster or not, and then you're going to compute each nodes and compute the answer for them, right? So then we get something like this. Each worker has their own partition of the data, and they do the operations. And then we have to, when we bring it back, we have to combine it, right? Right, and so now we have to, we do what we call the shuffle, right? Each worker says, okay, I've got A, you do B, and I'm going to do C, right? And then I'll send you all my A's, and you send me all your B's. And this is what's really is time consuming, because you're doing a broadcast of data. Right, so you have to be careful where the computation is being done. Okay. Using operations. Now you got to start paying close attention because things are going to get subtly complicated. You know, so here is a program where I have a function, and I'm going to create my Spark session, and then I'm going to do what? Well, just create a range. Okay, I'm getting numbers, 0 through 15, and I'm going to then coalesce the answer and then count on it. And in Notebook, I got, well, we get print start, and then we get print end, and then I get 0. So, various questions. What happened here? Run that print statement.
You didn't get called.
What got called? The problem is, where is it being executed?
A different thread.
If it's on your local machine, well, it's on a different thread, and so that thread is not connected to standard output, right? That also answers why is counter equal to 0? Because all this is being done in a separate thread. And so it's not changing the count or the counter on the master thread, right? So we have to be careful on where things are being executed. And then if you look at the command line, right, then we get all these outputs. Because those threads are not connected to the standard output, which Notebook captures, and it's all being done right in a different order because it's being formed off of different threads. And so it's important. You have to always be aware of where it's being executed and when. And are we doing it in Python? Are we doing it in Spark? Is it a Spark data frame or is it a Panda data frame? Okay, if you want to run a cluster on AWS, things become different. Now, it is possible to open up a notebook and run, and then do the standard notebook thing. We type in something to execute, and have that execute in AWS. Of course, you do realize that what that means is you are then, if you're using a cluster of 3 machines, those 3 machines are yours, while you're slowly typing in everything and executing and re-executing. So you're running through 3 machines worth of time as you sit there and think about what I should type in next. I haven't done it. There's another problem when you submit a job into this. One is you can say, well, just give me a low end, I don't care when it runs, just run it in the next couple days or a couple hours, right? And you get this spare machine. Or you can say, do it now, and that costs more, right? And also, when you spin up a cluster, it's not like it happens now. I mean, you have to allocate the machine, and so 5 minutes later, your program's ready to run. So when you're doing a notebook and AWS, you may be getting charged a lot of extra just so you get that real quick turnaround time. I don't know. So if we're going to submit a batch job, we need a program, not just, here's, 5 cells we want executed in order. If we're dealing with Python, we don't have to worry so much about packaging, although once the program is large, you then want to combine a bunch of Python code into groups. We talk about how you run it on your local machine as you would AWS. And then, of course, when things go wrong, you like to know what's going on, and so you worry about printing things out or logging. And you have to worry about file references. Because once you go to AWS, it's not your normal file system. So here is just a simple little program, and I then have to get my Spark session, and get that, and then I can then call, get a range of a bunch of numbers, and then I'm doing an operation and collecting it so I get the answer and I can print it out. And then the standard Python thing of, okay, this is main, then here's what you do. All right. Now to run this, so I installed Java 8. You don't want, you can have Java 9 or 10 installed, but you also need Java 8 installed. And you need the Java path set to Java 8, because Spark's going to look at the environment variables and see what Java to run. I then installed Spark in a top level directory called Java. So I put all my Java stuff. And also then which Python to use. So I set these two. There's also a way of setting up so that you can run Spark inside of Jupyter notebooks. Last year that worked fine when I had both set up. This year when I tried it, it didn't work because it got all these errors, and so I had to comment out all the things I did to make it run in the Spark notebook so I could run it in the command line. Just a warning. And then there is a command called spark submit, which is in the bin directory of your install, right? And I put that spark home/bin in my path. And there's also an sbin. And so that's Spark submit run this way is just going to start Spark. It's going to create the master and slave nodes, and it's going to run that program. And again, I'll warn you, every time you do this, the first line is unable to load native Hadoop library for platform using built-in Java classes. Unless you're running on a Linux machine and installed various things, that's what you're going to see. And then you get the default is you get all the logs, and it's modified. Last year I had 120 some lines of output. This time I only had 63 lines, and then there is my output in the middle of this. There are a lot of configuration files you can set. So in your Spark home/config, there is a log4.properties.template, which you can then convert to just a log4.properties. And to get rid of all that verbosity, we can then set the log category to higher level. And then when I ran it, I still get the warning, and then I just get my output, which is nice until you need to know what's going on, and then you want to turn those things back on because you want to be able to put print statements in. And okay, another subtle point. You don't want to hard code input files, output files in your Python code. For one, the default on Spark is not to overwrite files, right? And the reason is, I mean, using Spark, it usually means it's going to take a while, right? If it's going to take 20 seconds, I mean, why bother Spark? Just do it in Appending, right? So you have a Spark job and it runs for an hour and a half, and then you go, oh, look at the results, okay, I'm going to run it again. And you accidentally hit it, and you're in the same output files. You don't want to erase, right, that hour and a half run or a 2-hour run, whatever it took, right? You get 10 machines running for an hour, and it costs you a little bit, right? So the default in Spark is when you try and write to files that already exist, it gives you a runtime error and stops. So you really want to be able to indicate on the command line, here's my input files, here's my output files. So next time you run it, you can change it so that you don't overwrite, or you don't get that error message and have to run it again. All right, so there's a simple example where I, simple function to, do the standard Python parsing of the command line. And then we can just call Python it and do a bunch of stuff, right? This is straight Python code. And if you're a Python person, it's like standard default. And so another little simple program, right? Here is my Python code, right? Where I create a Spark session, and then I get my range, and I'm going to basically select every other one, write one with. And then I'm going to write and save the file. Now what I'm doing is I'm going to read the command line, get where the output should go, and then that's where I write it. Yeah, nothing. Now when I do this, right, what's happening is I have a default, so it's on the default, right? Now what's happening is the default is output, so I get a directory for outputs. You always get a file called either ._success or _failure, right? It's empty, it's a 0-byte file. And then since I ran it on my notebook has 6 cores, and for some reason, Spark thinks that there's 12 cores you can use, so I get 12 files. For each node you're running, when you do output like that, you're going to get the output from that particular node. And then, the part 0, I get a bunch of them, and then part 1 that starts at 283, right? Part 2 starts at 1. Okay, so you get and then I ran it again, and okay, again, get this runtime error, output always exists. Some of you will make this mistake. We can change the default, but you have to do it explicitly. So here I'm specifying the output, right? I'm doing several things here. One is Spark submits all the command flags before your program are sent to Spark. All the command flags after your program are sent to your program. Right? There's a bunch of flags we can send to Spark. Here I'm sending master local, everything's run a local machine, and if I indicate a number there, that's how many nodes I want. The default is a star, which means use all the nodes you detect. And so in this case, I only got 2 files because I said I only want 2 nodes. Okay, every time we do this, we spin up Spark, it does things, and the whole thing's just down, right? We can start up the master node and tell it how many nodes we want and have them running all the time, and then we can just submit to the existing system, right? Which mimics more what happens when you run on a cluster. So start master, right? It starts up the master node and it keeps on running until you stop it. So if you go home and you do it, and it gets late and you go to bed and you wake up, it's still running, right? And it tells you, right, Spark putting the master node. Well, I should change it because this is when I ran it last time. It's the name of my machine. Machine names is changed because campus security has tightened, so they name my machine. It's locked down. And so this time, instead of it being RE2 local.out, it actually was CO College of Science, Computer Science, and then the ID number of the machine, and then that's the port number, but this is running in port 8080, and so when you do this, you can copy this and then go to port 8080, and you will then get information about the master, right? How many workers, how many applications have run, how many complete applications. And once you've got applications, you can click on them and see information about them. including seeing the standard error and standard out for each of the applications. And then I can start a slave, and then I have to tell it how to connect to the master, which I have to give it the master node. And now you have to keep separate. This web page is at 8080. That's just a web server page you can access. Right. The master is accepting connections from slaves at port 7077. Now, for some reason, the first several times I ran it, I should have gotten, they were completed. It didn't happen the first several times. Later on, it happened. I'm not sure why. I didn't get that report. And now it gets to be tricky because I still use Spark submit to submit the job, but I have to tell it where to go, right? If I don't tell it where the master is, it's going to try and run another master and run it on that master. So I just specify where the master is. All right. For some reason, eventually I started getting how many completed jobs there were, and I can click on them and see what's going on. So this becomes similar to what happens in AWS, right? But you're going to run in batch mode, and then you can look and see if it's running or not. And when it's unrunning, then you can start looking at information about the log files, etc. And when you click on one of those applications, you get another page which shows you, how much work there, how many cores, how much memory was, and the standard out and standard error. You click on these, you can then look at the log files. And we can start and stop various commands. And then the Spark submit, we've got the class. It's not really relevant when we're in Python. When we're in Java and Scala code, you have to say what's the main class you're going to start with. Resorting mode. We can give configuration settings at the command line. A bunch of other options. And then, if you're running Java or Scala, you have to give it the jar file to run. Your Python is just a Python file. And then all the application level arguments. So there's lots of things we can specify: the name, the master, logging, memory. The local one thread, how many threads you want. How many failures you can allow per node. Again, there's just various ways of starting jobs. And so we can give it a zip file or an egg file or a straight Python file. People familiar with Python egg files? That's their way of basically taking a bunch of separate files and combining them into one so you can When you're writing small programs, you can just have one file, right? But as it gets larger, I mean, it doesn't work. It's like, where is it? And it's, you scroll up there, scroll down there. And whenever we can set configuration options in the code, in the command line, and then the configuration file. And the configuration file has the lowest priority, so anything that's on the command line is going to override what's in the configuration file, and anything you do in the program is going to override, right, what you do in the command line. You don't want to set really your configuration. Here I'm setting the master, right? You want to avoid doing that in your code because if you want to change, you have to edit your source code, and at some point you'll want to run it locally, make sure it's working right. Then you want to upload to AWS, and if you specify, run it local, what's that going to do on AWS? I mean, and again, okay, I said it before, you don't want to hard code on the file. We can override it, right? Mode override, but you probably don't want to do that. A week or so ago, I was contacted by a student of biology, and they're running these jobs that take days, like weeks, and there's a power outage. And they just lost, right, a whole week. They stopped the program, the machine died, and then you're just asking for trouble, right? Yeah, the print statements don't work very well on the slave. Some students say they can see it, but they're like running through all these log files and trying to find it. So Spark uses the standard Java log4j. And so here's an example of, I'm getting the logger. So I'm getting the logger file, here I'm getting the manager to give me the log for the underscore names, and standard Python thing with the name of the process I'm running. And now I can start calling info and start and error. And then when if you indeed have it, you start getting main, and then of course, if you're doing info and you don't want all that, you're in trouble. So there's different levels, right? The standard, this is pretty standard. Most places now logging as off, fatal, error warning, info debug, right? And you can specify, what your output you want to see. Right, and so here we set it in code. You also do it in a configuration file. Again, yeah, you probably don't want to set it in code. Right, so this is the standard one. You change this to higher level, it's going to. Okay. Last year I could run this program both in a notebook and using Spark directly. This year I can't. And I'm not sure why I didn't try going back and use my old version of Spark to see the difference. What's happening now is I could go, remember, this count method is going to be run on the worker nodes, right? So how does this count value get copied over there, right? So last year, apparently, it was being copied over for me from the master to, but this year it was not, right? So I run this program, you get a runtime error saying counter not defined, right? Because you're running this not on the master thread, you're running it on the worker thread. And so they bump up a couple versions, and the new version doesn't do it, but it makes sense. It's probably better this way because you think it's going to do something useful here, but you're not, because, right? Doing it this way makes you think that you're doing it sequentially, right? And it's happening in parallel on different nodes, and the master is not being updated. So it's better that it's not copying globals to the local ones, because it's not going to do what you think it's going to do. Okay, it's a good place to stop. I'll send you email tomorrow what's going to happen